I will not talk about all 40ec, I will talk a little bit what 40ec is about, and then I focus on things, I called it herding the cats. So everybody who is here for cat videos or cat pictures, sorry, go to YouTube. I'm talking about industrial IoT hardware, PLCs, intelligent I/O modules, sensors, actuators, all of them we want to get under control, we want to manage them, we want to program them. So we just not only want to get data out of them, but we want to have them in our industrial applications. So let's see how this thing is working like that. So 40ec is an environment for programming distributed industrial automation solutions. So what do we have in industrial automation? We have many different kind of devices. So you see here, I think there's a laser pointer, something like a PLC, valve terminals, other PLCs, remote IOs, maybe an embedded board. So some people are now using Raspberry Pis or industrial Raspberry Pi stuff. Maybe some sensor who is measuring pressure in your tank or stuff like that. And they all are networked together via some networks. We don't know what. So I don't want to throw any communication protocols on you, but if you think we have lots of different IoT protocols, double the number and then again, and then you are on the industrial protocol level. Good. So for that, and the problem is, normally, when you go in an industrial automation plant, each of these devices has to be programmed, maintained, managed with an own tool you have to buy by the vendor or get from the vendor of your hardware. And what we at 40ec want to do, we want to provide you with means how you can better program these systems. So also more advanced systems, we call it domain-specific modeling. So we have a domain-specific modeling language called IEC 61499. So it's the only time I will talk these standards. Since a few years, I'm also heading this standardization working group. So I know a little bit about the standard. So from 40ec, the main element, and which costs us the most effort, is a tool. So we have a 40ec IDE, we call it, and so you manage your projects, you model graphically your application, your control application. For example, you want to do a closed loop control of a tank level while at the same time maintain a heat or pressure in order to produce beer. Very simple task. You need to heat a little bit, you need to pump a little bit, you do some ingredients within, and the better you do it, the better the beer. Or the better the recipe, the better the beer, this depends. And then you model also what kind of devices you have. So you can model, I have this PLC, this other PLC, and they are connected via a protocol called maybe OPC-UA or Ethernet IP. And yeah, and then we want to deploy these things into the devices. And in order to support you, we developed something called 40ec runtime environment, and to make it easier to spell, we call it Forte. And Forte, as the name implies, gives you power. And Forte is the thing I want to talk today about, because Forte helps you that you can now talk from the IDE with all the devices. And yeah, we provide also some, wrong direction. We provide also some libraries and examples to see how this language is working. We are also working on tutorials and videos and all the stuff that you know. Because it's a new language, it's a little bit different than programming industrial solutions before. And we do this not only for beer brewing, we do it for a lot of different application domains. So this can be factory automation, robotic tasks, smart grids, process industries, and pharmaceutical, chemical, food and beverage, beer brewing, machine automation, or also home automation, building automation. All these domains have the same task. We have lots of different devices that we need to get under control. We have lots of different networks. And in 40ec, we have a flow. So we have now our 40ec, our not 40ec device. So it's a PLC you buy at some vendor nearby. So near Stuttgart, there are lots of PLC vendors. So you can go to them and say, I need a PLC. And on the other side, we have the IDE and the source files of our runtime environment. And this is where you start so far. And yeah, our workflow is now that for all the types you modeled here in your application, currently you have to export some code. So you generate your library of functionality, for example, the PID, so proportional integral derivative, closed loop control algorithm for controlling the liquid level of your tank. And then you need something, here it is, target compiler, which you take, which is specific to this device. Whoa, what's going on here? I made it black. Oh, if you press long, it gets black, cool. And then you get something what we call platform-specific version of Forte. You put it into your device, you see it here, and then you can use your device in a FortiAC environment. So you can go and press in FortiAC IDE the download button, and FortiAC IDE will connect with your device, will configure it, will instantiate the, we call them function blocks, the software components, will wire them together, configure how it communicates with other PLCs, and this can then be dynamically and can be changed. So if you later on find out, okay, you have to change something in your application, you just, this is crap, your button, you connect your FortiAC IDE, change it, and redo it. So where's the problem? The problem now is that we at FortiAC, we are faced with quite an amount of devices. So and this brings us quite into some troubles, because when we are talking about multi-operating system support, we are not talking about Windows, Linux, and Mac OS. No, we are talking about real-time operating systems. Systems not POSIX compliant. We are currently supporting 5 operating systems, 5 more are in the making. Then we are talking about processors, little endian, big endian, processor architectures like Super H. I don't know if any of you have ever used Super H processors. It's an old Hitachi. Or ARM PowerPCs, Intel's. 8-bit, although I don't see 8 bits very often, I even don't see 16 bits very often anymore. So now we are talking about 32-bit, 64-bit. But even then, just moving between the bits may change how your program is working. And then not to speak about target compilers and cross-compile environments. You cannot rely on any libraries on these operating systems. And this brought up, and this was from the beginning in the design of when we started. So when we started development this thing, this was around 2004, we already started and said, okay, we start with a Linux, a Windows PC, and 3 embedded devices with 3 different operating systems so that we get some first platform independence. And this is the result, what came out of this. When you look at Forte, this is roughly the above part is what you get around this part here. So here is all the things that are needed that our 4099 applications can run there. So you see here we have something called device management. This is a thing that interacts with the tool, and the FortiAC IDE can connect to this device management, and it will create, delete, monitor our applications. So here in the middle we have the control applications, which you download into your device. We have then execution things. So in our domain, we're also talking about real-time execution, so real-time constraint execution, like cycle times, like latencies, priorities, things that have to be kept in order that in the end, your control, your beer will be good, which is important. And below that, we introduced something, a very thin layer, we call it hardware abstraction layer. I'm not sure if we really should call it so high sophisticated. It's just 5 classes. But these 5 classes are very important for us because with these 5 classes, we wrap any operating and system-specific stuff inside. Most important, multi-threading, mutexes and semaphores, memory timer, so that we have our time for the real-time execution. Memory management is also always a topic on these small devices. The smallest device FortiAC can run on has around 256K of flash and 64K of RAM. And there we also have an operating system together. So this is where we have to share with the operating system. And yeah, network. Network is also an important thing. There we have quite a sophisticated infrastructure you see on the next slide, which allows us to really easily plug in support for different networks. And for example, we have MQTT with PAHO inside, which is used a lot, especially in the home automation domain. So I know many people connecting then PLC devices like this thing, which is then controlling lights and controlling the blinds, and interacting with Eclipse Home Automation. Upcoming for us, I would say the most important protocol is OPC UA, currently a server. I could talk alone 10 or more minutes on OPC UA. Here you see also our operating systems. So POSIX stuff is quite easy to get running. Here it gets more and more interesting. FreeRTOS, which is used on many of these new Cortex M3s and Cortex M0s. Well, it's a challenge to get it running. For example, we just recently have a first version of RCX, which is a special operating system by the company Hilscher. The complete network stack is different than anything I've seen before. But it was not fun to get it running. And yeah, you see here what's going on. We have lots of different boards for Raspberry Pis. This is something the time today is a little bit too short, but the important thing is not only the hardware support. In the end, in order to control something in an IoT device, you need access to sensors and actuators. And we also made an abstraction for sensors and actuators in our runtime environment so that you can model in an abstract way, I need a sensor, a digital sensor, I need an analog sensor, and get this platform independence. Yeah, and as you see here, more to come. Unfortunately, I cannot say much. One slide. There's just one outlook I want to bring, which makes it then even easier. We are currently working on integrating here a Lua engine, so we already have a prototype for that, because we can then skip this right part, and this has to be done only once. And all your applications, so your IoT device will get completely dynamically configurable. You can change your program, your real-time closed-loop industrial control program, without the need to touch a target compiler. Because this is really the pain in the ass. Target compilers are very often incompatible. So you cannot install more than 2 or 3 on your system. And with that, I thank for the time. Sorry I overdid. And yeah, I think one question is allowed.